Hi, welcome to the Embedded Apprentice. I'm going to show you something really cool today. We're going to dive into some of the technical details of how something works. It's really applicable to embedded systems. Then at the end I'll jump up a few levels and talk about why this is really cool and why it's important. So I have here my old Kindle. Can you see this? When I move it, the screen changes orientation. How does that work? So happens right here. I have the little Apprentice K64 board. It's hooked up to a USB port to give it power. I want to know if you can see, as I turn it and twist it, we'll do a close-up of this, the LED changes color right here. Hopefully you can see that. How does that work? How does my Kindle, your phone, know when you twist and turn it? So the way it works, this little chip right here is an accelerometer and magnetometer. We'll look at the data sheet of it. And what it does is it tells how this is oriented relative to the magnetic field of the Earth. Very cool technology. But what I want to know as an embedded developer, how does my processor talk to the accelerometer? Let's look at that. So the way these two parts communicate, this is the processor chip, this is the accelerometer. They use an i2c bus, or a two-wire bus, to communicate. I've hooked up the logic port, which hooks up to my PC through this USB cable. This acts as a logic analyzer, so we can see what the signals are doing on the board. I plugged into the two wires that are used by the i2c bus, and I have a ground wire. And then the board is still in the same mode. You can see how the LED changes. Let's look at what the signals are doing on the computer.
So the first question you may be asking is, how did I know which pins to hook that up to? Well, this is the Freedom 64K User's Guide. It's freely available from the NXP website. I went to the section on the accelerometer and magnetometer. That gives me the part number. The I2C bus is this I2C0 SCL, which stands for S-Clock, and I2C0 SDA, serial data. They go to PTE 24 and 25. The next thing to look at is the input and output connectors. You can see here PTE 24 goes to pin 20, PTE 25 goes to pin 18, and I know that the shield on this is ground. I could have also hooked it up to pin 14, which is the ground. So the accelerometer, they tell if it's an NXP FS OS 8700CQ. I also downloaded the datasheet for that. Here's the data sheet for that. 6-axis sensor with integrated linear accelerometer and magnetometer. Pretty cool. Now if we look at what's interesting, most of all, to an embedded developer, if you're going to be writing firmware for this and you want to talk to it with software, jump straight to the register description. So these are the commands. Think of them as registers or hardware locations inside the part that you can talk to. And this one's interesting to us, out X MSB. So this is going to be the X-axis most significant bit, followed by the out X least significant bit. So now I've jumped over to the logic analyzer window. This is where we're going to look at the signals from the wires that I've hooked up to the board. You can see here I've set up two wires as being I2C S-Clock, I2C SDA, so this serial data. This little up arrow means we're going to trigger every time S-Clock has a rising edge. Set the sample rate to 500 kilohertz. That's very important, but we'll go into that more later. Looks pretty chaotic. It's just jumping all over the place. I'm going to wiggle the board a little bit and stop it and try and capture an actual reading of the state from the board. So you can see when I captured it, let's see what's interesting. Here it's doing a start, right, 0, 0, so it's trying to get the status. So I move it over, we see a repeated start, a read from 1DH, 0, 0. So this is interesting. I2C bus can have up to 128 or 127 devices on the bus. And each device has its own unique address. So this device is all by itself on the bus, but it happens to be at address 1D. That's the number assigned to it, so whenever the processor outputs a 1D after a start, this device knows the processor is talking to me. Then the processor sends an acknowledge. It says, yes, I'm here, I want to talk to you. That's how this works. Setting up the sample rate to 500 kilohertz is very important, but it's something that we can go into later. I'm going to try and capture a real reading where we're actually getting the data from the device. So the I2c has two wires. So these are the two wires connected up to the logic analyzer. What I like about the logic port, logic analyzer, it has a translator, so it'll look at those two wires and tell us what's happening on the bus. It translates I2c bus for us. So we can see in this transaction there's a start, write of 1D to address 1, repeated start, a read, we read from 1D, and then this is the actual accelerometer data coming back out. One thing we can do is look at the source code. So if we look at the source code that comes downloaded straight from the NXP site, this is an example called Bubble. This file right here has the main in the file bubble.c. This is where all C code starts. You don't really need to know C code to follow along with what we're going to do on Embedded Apprentice. It doesn't hurt. We do some setup. We initialize things, set up the I2c bus, and then while one, which means loop on this forever. So we're going to execute this code over and over again. We do fxos read sensor data. That's this function I have displayed over here on the right side of the screen. And it's going to read the sensor data and return it in this array pointed to by sensor data. So it does a read reg into temp buff of 6 bytes. Temp buff is 6 bytes long. Now if we go back and look at the logic analyzer, you can see we do a read 1, 2, 3, 4, 5, 6. Remember where we were at. 7, 8, 9, 10, 11, 12. And in the code, we do the read of 6, a second read of 6. We copy the data from temp buff into sensor data, and we return that we were successful in reading. It then takes the X data and the Y data and converts that into an angle, then uses that angle to set the LED. And that is how the sensor and the board and the microprocessor are talking to each other.
So the I2c bus is the way that devices know to flip their screen. It's a common bus. It's been around for 20 plus years since I've started working with embedded systems. If you think about things, the processor, the parts that I'm showing you, they all came from Freescale, which was bought by NXP, which is now going to be bought by Qualcomm. So these companies are going to come and go. Will they make that same processor, the Kinetis K64, in 20 years? I doubt it. My computer has a couple of I2c buses on it. The x86, the Intel processor has them. Every processor is going to have an I2c bus. There are hundreds, thousands of peripherals that talk this, accelerometers, memory chips, all kinds of things that you can't even imagine all use I2c for communication. It's usually the way that your audio chips get set up. It's in everything. Your phone has one, your computer has one. If you're looking at me on a computer, it has an I2c device. I can guarantee that. So as an embedded developer, what do you want to learn? Do you want to learn the latest processor? Maybe you need to know that. It's useful information. But if you really want to learn something that's going to help you for your whole career, what you want to do is subscribe to the Embedded Apprentice. We're going to go through different things like this, communication protocols, the links between the chips. That's the stuff that's great to know, because that's the stuff that's not going away tomorrow when Qualcomm gets bought by the next company and the bigger fish eats the smaller fish. So keep tuning in, please subscribe, and we'll keep producing videos for you. Thank you.